Hello, here we are on section 7.3. I have a few examples that I'd like to show you. Let's start at number 21. If we're taking the fourth root of this, the first thing we look for is, can we simplify anything under the radical? It doesn't look like we can, so I'm going to split it into its two parts. The top, because 8 is not the fourth root of anything, we can't simplify that. The bottom, 8 divided by 4, gives me x squared. Number 23. 23 says the cube root of 2x over 81y to the 12th. Again, if I could simplify 2 and 81, I would do it at this point, but I can't, so I'm going to split it into the cube root of 2x on top and the cube root of 81y to the 12th on the bottom. Again, on the top, nothing really simplifies there, so I'm going to leave it like that. On the bottom, I know that we're doing the cube root. 81 isn't a cube root, so I'm going to split it into 27 times 3. The 27 can come out. The cube root of 27 is 3, so that comes out front. The cube root of y to the 12th is y to the 4th, and we have the cube root of 3 left over. Now, if we were on the next section, we would rationalize our denominator because we are not to be leaving radicals in the denominator. But for now, we're going to leave it this way. But in the next section, we'll be simplifying this. Let's then go to 27. 27 says the square root of 5x squared over 4y squared. Again, nothing simplifies as it sits, so we split it into two different parts. On the top, the x squared will come out as an x. The 5 stays under. On the bottom, the 4 comes out as a 2. The y squared comes out as a y. Notice my fraction bar goes over everything there. 29. It says negative cube root of z to the 7th over 27x cubed. Again, if we can simplify anything, that's better, but in this case, there's nothing to simplify, so I'm going to split it into its two parts. On the top, I'm going to split z to the 7th into z to the 6th times z. Now, why did I pick z to the 6th? Because it's the biggest number, less than 7, that is divisible by 3. 6 divisible by 3 gives me, the negative is already out there, gives me a z squared. And the 1z here is left under the radical. Don't forget the 3 for the cube root. On the bottom, cube root of 27 is 3. Cube root of x cubed is x. Remember, this little number right there is very common to forget that. Let's now move to question 62. 62 says we have the cube root of 10 over the cube root of 2. If we knew 10 or 2 were perfect cubes, we would certainly simplify at this point, but since neither one of them are, we're going to try to write them as a single, just the opposite of what we were doing in the first few questions where we were splitting it. Here we're putting them together, and we can simplify 10 over 2 into the cube root of 5. Question number 64, we have 7 times the fourth root of 162 all over the fourth root of 2. Well, let's try to simplify this. Again, I look on my card and see that 162 is not there, and I know that I can't do the fourth root of 2, so I'm going to rewrite it as a single radical. Fourth root of 262 over 2. I simplify, I get 7 times the fourth root. 162 divided by 2 gives me 81. 81's on my card. The fourth root of 81 is 3. 7 times 3 is 21. Let's now jump to 68. 68, I have the cube root of 128x cubed over the negative 3 cube root 2x. Same as the last one, 128 is not a perfect cube, nor is 2x, so I'm going to put them together and do some simplifying first. So I'm going to go with 1 over negative 3, because this part stays outside the radical. And then I'm putting all of it under one radical to simplify what I can. 2x. Let's simplify. 128 divided by 2 gives me 64. X cubed divided by x gives me x squared. I can take the cube root of 64. That's 4, so I get 4 over negative 3. And then this x squared isn't big enough to come out, so I'm going to leave it underneath. Fraction bar goes over all of it. Let's move on to number 70. We have the square root of 270y squared over 5 square roots of 3y to the negative 4th. Here we have a negative exponent. Again, we're going to be putting them, since this is a square root, this is a square root, we're going to rewrite it. Notice the numbers outside I make into a fraction. You can't just put the 5 on top because it is on the bottom. And then I'm going to write the whole thing under one square root so I can simplify what I can. When I simplify, I get 270 divided by 3 gives me 90, and y squared divided by y to the negative 4th. You subtract when you divide, so 2 minus negative 4 minus negative makes it plus, so I get y to the 6th. Notice that everything is on the numerator now. Nothing stayed in the bottom, all that moved out. So I'm left with 1 over 5 square root 90y to the 6th. Now let's bring out what we can. 90 isn't a perfect square, so I'm going to rewrite it as 9 times 10. Square root of 9 comes out as a 3. 3 times the 1 that was there is 3. Y to the 6th square rooted gives me y cubed. And I have this leftover 10 that I'm going to put back in the radical, all over 5. Can I simplify the 10 under the radical and the 5 outside the radical? No, because one's in a radical and the other one's not. They are not the same kind of numbers, so you can't simplify those. And 72, the last one. I get the 5th root of 64x to the 10th y to the 3rd all over the 5th root of 2x cubed y to the negative 7. Since we're both 5th roots, we're going to write it under the same radical, 64x to the 10th y to the 3rd divided by 2x to the 3rd y to the negative 7. Let's simplify that. 5th root, 64 divided by 2 is 32. X to the 10th divided by x to the 3rd leaves me with x to the 7th, and 3 minus negative 7 leaves me with y to the 10th. Remember, when you divide, you subtract the exponents. Let's simplify what we can. 5th root of 32 is 2. I'm going to split x to the 7th into x to the 5th and x squared. Bring the x to the 5th out. 5th root of x to the 5th is x. And then y to the 10th comes out as y squared. And we're left with our 5th root of x squared. Thank you and good luck. Bang.